Welcome to homework.
So we're asked to consider a prism, which I've drawn here, where the apex angle of the prism phi is equal to 75 degrees. And it wants us to find the minimum incident angle for a ray for it to emerge from the opposite side and not be totally internally reflected. So we have the ray coming through represented as the red line, and we want to find theta 1. So it comes in at an angle theta 1, then it was refracted theta 2, then theta 3 and theta 4 are the angles relative to it leaving the prism. And the index of refraction of the prism in is 1.58. And we're considering this prism sitting in air with an index of refraction in sub A for air of 1. Okay, so for total reflection at the second surface, we can go ahead and use Snell's law, which says that n times the sine of theta 3, so this is the second surface on the right, is going to be equal to n sub A times the sine of theta 4. Right? Okay, so the maximum value of theta 4 before total internal reflection takes place at the second surface is 90 degrees. Thus, for internal reflection not to occur, we have to have n times the sine of theta 3 to be greater than, or excuse me, to be less than n sub A, right? Because it has to be less than when sine of theta 4 is the sine of 90 degrees, which is 1. So it has to be less than n sub A, which means that it has to be less than or equal to 1.00, because that's n sub A. Therefore, theta 3 has to be less than or equal to n sub A. Well, it has to be less than or equal to the inverse sine, because to get theta 3 by itself, you have to take inverse sine of both sides of n sub A divided by n, which means that it has to be less than or equal to 39.27 degrees. So that's the minimum angle that theta 3 can be in order to have it not be totally internally reflected. So we find the reflection angle at the second surface by taking, we need to start a new page for this, by taking 90 degrees minus theta 2 plus 90 degrees minus theta 3 plus the apex angle phi has to be equal to 180 degrees, right? Because 180 degrees has to be the total angle of the triangle. Therefore, theta 2 has to be equal to phi minus theta 3. And we were given phi, we're told it's 75 degrees. And we're given theta 3, we found that theta, well, we weren't given theta 3, we found theta 3, and we found that has to be less than or equal to 39.27 degrees. Therefore, theta 2 has to be less than or equal to, or has to be greater than or equal to 35.73 degrees, which would just be phi minus theta 3. Okay, so for refraction at the surface, now we have the following. We have n sub A times the sine of theta 1 is equal to, again, this is just Snell's law, n times the sine of theta 2. Let's redraw that theta, that didn't look very nice, times the sine of theta 2. Therefore, theta 1 has to be greater than or equal to inverse sine of n divided by index of refraction of error, n sub a, times the sine of theta 2. Therefore, theta 1 has to be greater than or equal to 67 degrees. And we can box that in as our solution to the question.